In this video, I want to introduce the built-in abstract functions in Racket. So instead of writing do to all, which we wrote ourselves, there's a built-in map function to ISL that does the exact same thing as our do to all abstraction, right? Given a list of n0 and 1, produce some function applying over the value, right? So here's square all. It squares all the numbers in the list. So 2 becomes 4, 4 becomes 16. Instead of writing do to all, just Control F and replace it with map, right? That built-in function is going to do the exact same thing. Instead of keep if, right, filter. And the purpose statement is that it keeps only the items that passes some criteria. So here we have odds only, it consumes a list, and we have a filter here now. And this is the criteria. If it's an odd number, then we'll keep it. So given this list 1, 2, 3, 4, right, 1 and 3 are the only odd numbers, 2 and 4 are even. So yeah. Next is collapse to foldr. So we have some nums here. So we have a list 1, 2, 3, and some nums will just add up all the numbers in that list. So replace collapse with foldr, which just takes an operation, a base case, and then a list, right? And you're welcome to read the documentation more if you want to get all more examples. All right. So run this, all tests do pass. So here's another useful abstraction function, build-list. It consumes a natural number and then a function that consumes a natural number and spits out some x. And then this whole thing, this whole build list produces a list of x, right? So if you go to the documentation, build-list, right, it'll tell you what it means, right? So constructs a list by applying f to the numbers between 0 and n-1. So for example, if you want a list of 10 numbers, right? So build-list, you do 10, and then it has taken a function as its second argument. So a useful function that's built into Racket is called the identity function. And if you go look at what that does, right, it just spits out whatever is being taken in. So identity of 42 spits out 42. Identity of hello spits out the string hello. Identity of true spits out the Boolean true. So I think you get the idea. So if I run this, right, we just get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's 10 numbers in total. 0 is kind of taking the place of that 10. So if we add 1, then we'll get 1 through 10, right? So that's one way to use this second parameter to manipulate this list. So let's say you want to do build list 10. You want the square of 10 numbers, 1 through 10, right? Run this, we get 0, 1, 4, because 2 squared is 4, 3 squared is 9, 4 squared is 16, and I think you get the idea, right? So this second argument has to consume a number, and it produces some x. So we can write a custom function, build-list 10, and then custom function, as long as it consumes some natural number, and then it could do something with that natural number, and then spit out some x, right? So that's a huge hint for this upcoming to-do, right? Write a function even ends that consumes a number n and produces the first n even numbers. E.g., if we call even ends 4, right? The first 4 even numbers are 2, 4, 6, and 8, right? So I recommend you pause the video and try to write even ends, all right? Spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So let's just define this function. Even end, it's going to take some number n and then build a list out of it, where that n is going to be the amount of items. So we pass in 4, we get 4 numbers. We pass in 10, we get 10 numbers. But how do we make them all even numbers, right? Well, we're going to need to pass a custom function because the built-in functions in Racket will not help us here, right? We need to turn the numbers into even numbers. So we're going to do define custom. And then it also is going to take some number n. I'm going to call it I just to not get it confused with this n here, actually. All right. So there we go. All right. And we got to do something to that I, of course. So let me just template this out I. All right. So how this is going to work is build list is going to call custom with increasing numbers of n. So I is going to be 0. Right, build list and call custom with 0 and then 1. So custom, so I is going to be 1 and then 2 and then 3 and then 4, right? Like so. So it would just spit it up back out, right? Right, this would be the identity function. So if I call even ends over here with 4, we get 0, 1, 2, 3, 0, 1, 2, 3, right? So how do we turn all these numbers into even numbers? Well, this requires some domain knowledge of math, right? It's not really something that's innate to programming, right? It's something that requires you to know math. So if you multiply any number by 2, right, that will turn it even. So we just run this, and we run even ends of 4, right? The 1, so before it was like 1, 2, 3, 4. Well, the 1 gets turned into a 2, the 2 gets turned into a 4, and then the 3 gets turned into a 6. But we're still not there yet, right? Even ends, we want the first 4 even numbers, and this 0 is in the way. So how do we get all these? We also want, in 8. So how do we, manipulate this such that, how do we manipulate the original list of 4 numbers, right? Because we multiplied them all by 2, that's helping, but we're still not there yet, right? We want to get rid of the 0 and have an 8 there. Well, the answer is that we need to add 1 and then multiply by 2, right? So add 1 to the n, to the I mean, and then multiply by 2, and then we will get that. Even ends 4, list 2, 4, 6, 8. Just like this example. And we do, even ends of 10, we get the first 10 even numbers. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right. And yeah, this is what you're going to have to do in the future videos. You're going to have to be passing functions into other functions a lot more. So now let's move on to the next abstract built-in function, andmap. So andmap takes in a predicate function, and a predicate function is just a fancy way of saying that a function produces a boolean, right? It takes in a function as its first argument, and then a list of x. And this type x is going to be the same type as the input for the first argument of the predicate function. So they give us some examples of how you use it with andmap of odd, and given this list, produces true because they're all odd numbers. And if there's one even in here, right, let's say a 2, then this would produce false. All right. So you're probably wondering what these ... dots mean. Well, it means that it depends if you passed more things, right? You can pass in 2 lists, and then this would have a second argument. So let me demonstrate that actually. So andmap, right? Let's say greater than, and I'm gonna pass in 2 lists. So list 1 is 1, 2, 3, 4, and then list 2 is 2, 4, 6, 8, right? So what it's going to say is that, hey, right, is 1 greater than 2, is 2 greater than 4, is 3 greater than 6, and is 4 greater than 8, right? And the answer is no, because 1 is not greater than 2 off the bat. So I run that code, we get false over here, right? So yeah, if I do a custom function, right, this can be a custom function. So I'm going to say, compare, right? Because there's 2 lists here. So define compare, you would have to pass in a function that takes in 2 arguments, right? We'll call it x and y, right? So this x is going to be 1, and then this y is going to be 2, and then the next iteration, x is going to be 2, and then y is going to be 4. Next iteration, x is going to be 3, y is going to be 6, and then finally x is going to be 4, and y is going to be 8, right? So we can compare these, right? This is the same thing, right? We still get, let's see, compare is used here before. Oh, you have to move this up like so. All right, so now it's referencing, there we go, right? So we still get false. If we move this, right, then it's true because all these numbers are bigger than this number. We can do things to this, to the numbers, and etc. Right, these can be different types as well. So if I do something like moo, meow, and then wolf, and then bark, right? So now y is going to be a list of strings. So if I run this, it's going to say, hey, right, you're comparing greater than 1 to the string moo. That's not going to work. Greater than takes in numbers, right? So, I mean, less than takes in numbers, right? This is a less than symbol. So let's turn this y into, this y is going to be these strings. So let's turn it into a number with string length right? So are any of these less than, is x less than these strings, right? All of these. So 1 is not, 1 is less than 3, 2 is less than 4, 3 is less than, 3 is not less than 4, so it stops here and it produces false. All right, hopefully you get the general idea, right? You can pass in a third list, you would have to take 3 arguments, and etc. Right? So that is andmap. And similarly, it's the same for ormap, except it does or, right? So for ormap, right, as long as one of these is true, so ormap, right, and as long as one of these is true for the compare function, right, then it will produce true. And I'm pretty sure one of these is at least true, right? So is x is 1 less than 3? Yeah, it is. So this whole thing will produce true because that's how or is defined, right? So we set true here. Anyways, I recommend you read the documentation for more abstract built-in functions. And also note that the upcoming problems will be getting a lot harder. So just a reminder again that there are hints, right? Just click this hint and it'll tell you what functions that you need to use, and all you have to do is sort of cobble them together, right? So if you're ever stuck, right, do use the hints. All right. Anywho, that is about it for this video, and I will catch you in the next one.